In this video, we'll look at how to use the LatheEngraver in order to scan a profile of our workpiece. Now, there's a variety of reasons for why you might want to do that. For example, if you're doing a basket illusion piece and you want to use a laser on the LatheEngraver, then we have software already written that will actually follow this profile of the piece and put all of those horizontal lines in there, and I'll show you a little bit more about that later. There's also the ability to create a three-dimensional model from that profile. And some CAM software, things like Gerbil can import those three-dimensional models, and then you can do complex designs on those. In this example, we are using the LatheEngraver standalone platform, which is very convenient. So I can have my lathe doing other things while I'm doing this embellishment work. And we're also using one of these 3D touch probes right here. And the advantage of these probes is that they work in any direction. So while I have this zeroed out on this bowl right here, I could have this B-axis rotated at a variety of angles. And as long as this probe touches, you can see that turns red in any way. If it goes in, out, left, right, whatever, it'll trigger that probe. So these are convenient type of probe to have, as opposed to just having a limit switch type of probe. Now, there's several pieces of information that we need in order to do this scanning. And the first one is that we need to know what the diameter is of this bowl at the first point that we're going to measure. And that's only really if we're going to do a three-dimensional model of that, but I've just put a ruler across this and I know the diameter of this bowl is 180 millimeters. The other piece of information we need to know is how far we're actually going to scan on this bowl. So you can put a ruler across here and estimate what that's going to be. And in this case, I've estimated that to be about 80 millimeters. So with that information in hand, we can go over to the software and we can start putting in that information into this. Just as a note here, right now I have the B-axis zeroed, so I'm parallel to the Z-axis here, and I have everything zeroed out, which is something you should do anytime you're starting a new operation with the LatheEngraver. And in this case, I'm going to go to a specific plugin that we have, and this plugin is the scanning plugin. And this is one that I've written that does a variety of different things. So first off, when you're looking at this, we're going to be doing an X scan here, but this software also has the ability to do scans in the Z direction. So a scan means that we'll be moving along the X-axis and then probing the Z direction, or we can do this the opposite way. If a Z scan would move along the X direction, along the Z direction, and probe the X values for that. And we also have the ability to do an A scan, which is the rotation of the bowl and probing that. And that actually gives us the ovality at that position. That's not really used for anything yet, but it has the potential in the future to be able to compensate for the ovality of our piece while we're making cuts. The reference diameter is that 180 millimeters that I told you about before. The scan length here we said was going to be 80 millimeters. And the increment here is how fine a measurements we're actually going to take. You can get away with relatively coarse ones. I'd say 5 millimeters is going to be coarse. I'm going to do 2 millimeters in this case, which should give us a nice profile. And now the pull-off distance is how far the whole probe is going to move back after it measures. And in this case, because we're probing downhill, we don't need that to be a very large value. I'm going to use 3 millimeters here, but if we were probing uphill, we'd want that to be a larger value. All right, the last thing that we have here is the name for this. This is a piece of elm, so I'll just call this elm test 2 since I've already tested this once. And the last box that we have here is this create STL. And so the STL file is that three-dimensional file that I was mentioning. So once this scan is complete, it'll actually create a three-dimensional file from this as well. And in order to make this work, all we have to do is click the Start Scan button. And one of the neat things with this is that it actually gives you the profile as the scan is going on, so you can see how that scan is developing. Now this does take a few minutes to do, but it's not something that takes a really long time. It really depends on the size of your piece and what your scan increments are. And there you have it. Now we have our profile. So one of the things I'll do is I'll just show you where those files are. If I switch to this view, one of the things we have to do is we have to refresh these files after the scan takes place. And these are all stored in this scans directory right here, the scans folder. And this was the Elm test 2. This is the STL file, so that's that three-dimensional file. And then we have this text file, which contains all of the probe data that you see in that plot there. Now we can move on and show you what you can actually do once we have this profile data. Now that we've scanned our profile, we can actually do something with this. And the example that I'm going to show you is something that you would do, for example, with a basket illusion. What I have now is I've mounted a pencil lead bit on here, which I like to use for testing. But of course, if we were going to be doing a basket illusion, we would do this with, say, a laser that's actually mounted on here. The first thing that I'm going to do is I've moved to that 0 position, that first point that we measured for the profile, and I'm going to 0 everything here. So for XZA, I'm going to hit 0 and make sure that all of these values are at 0. And then what we're going to use as far as our plugin is this laser profile plugin. And this is, well, it's a plugin that's in active development, so it'll do a variety of things. But for the laser mode, we would select laser here. And then we can go down and we're going to select our scan file. And so our scan file in this case was this Elm test 2. This is the three-dimensional file, and this is the profile. So this will pull up our profile that we have. And if we want to, for example, just put beads in a certain region right here, we want to know that we're going to go to the right position. So what we can do is we can use some markers. So let's set a max limit. Let's say we think that our first position is going to be about here. That's going to be this edge over here. And our minimum distance in the X position is going to be, let's say, about here. So we can set those markers, but we want to test if those are correct. So we can then use this set target feature, and we'll test the maximum first. So we'll put that target right at that max position, and then we can simply give it the command, go to target, and you'll see that the whole thing's going to move over. It's then going to rotate the B-axis because it's going to actually position, because we have this profile, it's going to make that normal to that axis. And you can see that that's actually right about on this line that I scribed here, which would be perfect for where we want to be. And then we can also do the same thing. We can set the target and test this to see if our minimum position is correct. So there we've set our target. We can click go to target. It's going to move back, move over, adjust the B position, and we can see if we're at the right location. And actually that one looks pretty good as well. So if these two lines I've scribed here are the limits of our beads, we're basically right on that. And the neat thing with the software is that we give it the additional information that we have here. And this is an important one here. This is the distance between the surface of our piece and the center of the rotation axis. That's something that you have to determine for your setup. But we can give it the number of segments, and we can give it the feed rate and the laser power. And then all I have to do is click this write job, and it will actually give us all of the G-code that we need in order to be able to do those horizontal lines for a basket illusion, which may take you days to do by hand, but will just take you minutes to do with the LatheEngraver.